So signaling ka role in train operations is vital. So in that you can see block signaling, yard interlocking, train detection, and level crossing gate interlocking. You can broadly divide the signaling role into four different types. Of course, the advanced concepts of signaling are there. Okay, so they are gaining more and more importance. What are the advanced concepts? Warning system against SPAD. Okay, that is in the form of TPWS or TCAS or even ETCS level 2 and all. Okay. Then of course cab signaling, then CBTC is there, communication based signaling and all, uh, and moving block, centralized traffic control with or without train describer. These are all the advanced concepts of signaling which is yet to come. They are mainly used in metro signaling and all, metro trains, but they are coming to slowly to the mainline signals also. So the signaling is entirely depends on the works based on the general rules, GR and all. GR and all gives the specific definitions about various words used in signaling and all. Okay. So there is a list available that we will not be able to cover, but it is enough if you know that there are specific definitions for every word used in GR. Okay. So the important words are this Commissioner of Railway Safety. Okay. He is having a specific role. Controller. Okay. So facing and trailing points. These are the important things to understand. Any point will be a facing point or trailing point depending on the direction of movement of the train. So the same point will be a facing point for one particular train moving in a particular direction, and it will become a trailing point for the train moving in the opposite direction. Okay. Similarly, concepts like fouling mark, isolation. What is the isolation? Okay. These things are given in the definitions part of GR. Okay. So if you see the train running concepts, basically outside the railways, many people are not aware that driver doesn't have the steering wheel. That means driver will not be able to control the movement of the track in which route he has to go. So who will control the movement of the trains?
Signaling.
Signaling nahi, station master. Station master is in control of the movements of the trains. He will control on which line the train is to be received and to which line the train has to move. So in the manual old method, manually the points are set and locked, and then only the movement is allowed by the station master. That way, the station master will control the movement of the trains. The driver is only having the control over the speed. He can only control the speed. He can decide whether to stop or start or move. Okay. No steering wheels are available. Second concept is they have to follow one another in the same track. Okay. There is no precedence or crossing possible on a single track. A special arrangement has to be done for that. So how this special arrangement of crossing and precedences is done? It is done by forming what is called a station section. So now you have got the concept of block section as well as the station section. So in the block section, a train has to move and follow one another. They cannot take precedence or cross in the block section. So all these things can happen only in the station section. Another property of the trains is that the braking distance is very long. So the driver, even if he sees some obstruction, he will not be able to stop of obstruction and all. Normally, the road vehicles and all, they go by their own visibility and all. They will view, and if any obstruction is there, they themselves will be able to control the vehicle and stop the vehicle. Same is not the case with trains. Because the braking distances are long, they require much advanced information about the stoppage of the train and all. So this is where the signaling will come into play and help. Okay. So as you can see, these are the various modes. Here, in the other modes, they are not, their movement is not limited to a fixed path. Whereas in the case of trains, their movement is limited to a particular track and all. So then comes, as you said, station section and block section. So the protection in block section, protection in station section. So signaling provides protection both in the block section as well as the station section, but the concept differs. So in the case of block section, what is required to be done? No two trains can be there in the same block section. That is how the protection has to be provided. If at all more is there, that also with a suitable safety norms and all. So if in the normal absolute block system, between two trains, only one train is permitted. So that is protected by using what is called block instruments. So block instruments provide the safety by allowing only one train to be in the section. So this is called block protection. Okay. But block instrument as it is will not be able to ensure that the entire train is intact. That means when a train enters the block section and reaches the other station, the block instruments will not be able to say whether the full train has arrived or not. So there were cases earlier where a part of the train is left out in the section. But still, when the first part reaches the station, if the station master is not alert and observes it, he may close the block section and it is possible to allow another train into the section. Okay. So that is how the concept of BPAC has come. Okay. So block proving axle counters are provided. So this block proving axle counter is provided from the last 15 years or so, where the intactness of the train is also proved. So when a full train enters the block section, the number of wheels entering into the block section is counted, and when it reaches the other end, if the same number of wheels are received into the station, then the block section is declared as clear of the entire train. Okay. So earlier, what was the method used when BPAC was not there? How this was ensured? Can somebody tell?
Last vehicle.
Yes, that was manually decided by the station master. So manually, the station master has to ensure that the entire train has come by checking the last vehicle board put behind the guard brake van and all. Otherwise, he will exchange signals with the guard. So, because the manual ensuring is there, there are possibilities of mistake or error happening. And it did happen and resulted in some accidents and all. So that is where the BPSC will come into the rescue. Okay. So BPSC will ensure that the entire train has arrived automatically by checking the number of wheels rolling in as well as the number of wheels rolling out at the other station. Then in the midsection, the other type of protection that is being provided by signaling is by protecting the level crossing gates. So that is by interlocking the level crossing gates with protective signals. So the signal cannot be taken off unless the level crossing gate is closed and then locked. Okay. Then of course the other things like IBS and automatic signaling have come. Their main purpose is not only protection, their purpose is for enhancing the line capacity. So that way, signaling, which started for protecting the trains, now has become necessary for increasing the throughput also. So as the section becomes saturated, the number of trains required to be run increases, then signaling will come to the rescue with this type of methods like IBS and automatic signaling. So what is the IBS? As you all know, normally only one train can be run between two stations. But if the section length is long, then it takes more time for the train to clear the section and the next train has to wait. Instead of that, IBS provides that you can divide the section into two, put a signal in the middle so that two trains can be allowed into the section between two stations. So that way it is the easiest, fastest and cheapest way of increasing the line capacity. What is the other method of increasing the line capacity?
Sir, IBS full form, sir.
Intermediate block signaling. That name itself tells that intermediate block signaling means one block section is divided into two. Basically, it is a very simple principle. Your last stop signal, normally only one train should be there between your last stop signal and the home signal. Okay. What should be the distance between last stop signal and the top point? Normally, what is the distance between the top point and the last stop signal? Any idea?
1 kilometer. 1 kilometer. 1 kilometer.
1 kilometer. No, normally it should be limited to 120 meters also, but some places it may be more, little bit more also. Okay. So that is only meant for doing some shunting purpose and all. Okay. Suppose the same last stop signal, it is moved to the midsection. Then there will be, how much distance will be there between last stop signal and the top point? You have got a distance of say 4 kilometers or 5 kilometers. It is half the distance of the block section. Okay. Then
What is top point? Top point क्या है, sir?
top point. Oh, so I think that I have to explain. So point you all know. You all understand what
Yes,
is
yes, sir.
point?
Yes, sir. Yes, sir.
Okay.
Yes,
So
yes, sir.
point is the one which will allow the train to be diverted to different tracks. Okay. So top point is the one which is the last point of the yard. after the point is crossed, there are no further diversions. Okay, so it is the beginning of the block section. Okay, so but immediately after the top point, block section doesn't begin. Some distance will be kept around 120 meters or so, and then you have got last stop signal. So the
Advance starter, sir. That
the
is
same
advance
last
starter.
stop signal is also known as advanced starter. Advanced starter. Okay. Why it is called advanced starter is earlier there was provision that advanced starter is not compulsory. Okay. Only starter signal can act as the last stop signal, particularly when token instruments were there. Okay. So LSS was not compulsory, but with tokenless signaling coming, LSS has became the part of the block signaling. So LSS is compulsory. So that is the one limit, okay, for starting of the block section. So this between LSS and the home signal, one more signal is kept, okay, in the mid section, and now the section becomes two halves. First half is protected using a axial counter, and second half is protected using your block instrument. So that is how you can allow two trains to be kept between two block sections, increasing the line capacity. All of you are getting the point? RTJ. Okay. So you got some idea of what is IBS and all?
Yes, sir.
Okay. Similarly, automatic signaling is there. In the case of IBS, you can allow only two trains between two stations. Whereas if you take any major city, so the large number of trains leave the city in the evenings and large number of trains arrive at the station in the mornings. So there is a flow of traffic. So there, this automatic signaling will come to help. Okay. So where between two stations, for every kilometer you can erect a signal, and the signal itself will protect. So automatic signaling, why it is called automatic signaling is that signals are not taken off by the station master. The train itself will move, and when sufficient distance is there between the train and the rear behind, then that signal will automatically go to off position. Okay. So you suppose you have got 5 kilometers distance between two stations, then you can, for every kilometer you can have a signal. But the condition is that the entire section should be track circuited. Then comes the point, what is a track circuit? So what is a track circuit?
To detect
When track is occupied.
occupied position or not, sir.
Yes. So
Yes.
basic protection of signal is done. Number one, to protect the points. Number two is that signal is not taken off to a occupied line. So once you want to avoid taking off of the signal onto a occupied line, you must have some mechanism or method or tool to detect whether any train is available on the track. So track circuit is one simple electrical circuit where the track, both the rails are part of the circuit, and it will allow the detection of or absence of the train by making the rails as well as the axle as part of the circuit. So if you want to detect the presence or absence on a particular portion, that particular portion should be insulated from the remaining portion. So that is how you must have seen insulated joints in the yard portion. Okay, large number of insulated joints will be there separating two portions of the rail. And of course, nowadays they have all become what is known as glued joints, where what is the difference between insulated joint and the glued joint? Any idea? You have heard about insulated joint and glued joint?
Yes, sir.
So basically, insulated joint is, it is provided at site. You can remove the fish plates along with the engineering staff. Engineering staff will remove the fish plates, and a signal staff will give the insulations. And the special type of fish plates are used. Okay, milled fish plates. So the insulation can be provided, and then again the fish plates can be fixed again. So separating the both sides of the track, okay, electrically. So that is done at site. Whereas glued joint, the same thing is done at a factory level, and the entire piece will be insulated, but it will act like a single rail. Your fish plates will be there, but they are all glued, fixed with some sort of glue, so that it is not possible to open the fish plates. If glue joint becomes defective, then the entire rail has to be cut and then replaced. Okay. But the advantage part is that glue joint, pardon?
And is that called the LWR?
LWR is different. LWR is long welded rail. Normally, one rail consists of how much of length? 13 meters.
13 meters.
Okay, 13 meters, because that is easy to transport and provide on the track. But once you provide a 13 meters length, it has to be joined with the adjacent one using fish plates. These fish plates will cause lot of noise and discomfort and maintenance when the train moves over it. So it is advantageous if the rails are welded. Okay. So initially it started by welding 2 to 3 rails at a time. So that means number of fish plates have reduced from every rail to once in 3 rails. That is called short welded rails. That means your length of the track, continuous track without fish plates, is 13 into 3, 39 meters. That is called short welded rails. But in short welded rails, 39 meters, due to temperature variations, there will be small gap will change. Okay, so that will be able to tolerate the temperature variations. But as you weld more and more rails, okay, so the expansion variation difference will become more. Okay, so that is how normally more than 3 rails are not welded together. But now the technology has come wherein you can weld up to even a kilometer of rails continuously. So that is called LWR, long welded rails. But how the long welded rails, the problem of expansion of rail is tackled? That is by providing what is called expansion joints at the end of LWRs, number one. Number two is that can be provided only in the with PSC sleepers. It was not possible. LWR was not possible with wooden sleepers. With concrete sleepers coming, with the penroll clips and all, the rails are held. Okay, they are able to withstand the stresses developed. Okay, only at the last 100 meters the expansion is allowed, and that is allowed through what is called some expansion joints and all. That is totally a civil engineering thing. Okay, SNT signal has got nothing to do with LWR and all. Whereas glue joint is a part of the signaling. It is a signaling requirement. Track people doesn't require any glue joints. In fact, it is a bigger maintenance problem for them also. But in station yards and all, till some alternative technical solution is there, glue joints becomes unavoidable. Okay. So in the automatic signaling, the entire portion between the two stations are completely track circuited. A track circuit is having the limitation that it can have a maximum length of only 450 meters at the most, or in some special cases 700 meters. So number of glue joints have to be provided, and number of track circuits are provided, and then the train as it moves. Okay, if behind the train, if sufficient distance of safe distance is there, then the next signal will automatically go to off position. This is how the automatic signaling will work. Okay, so now we have discussed about the block section and its protection. Now let us, next important thing is station section. Station section is a unavoidable thing. Otherwise, normally a train has to go from one place to the other, one junction to the other, a distance of say 100 kilometers or 150 kilometers. So without the station section, then it is not possible to have a crossing or a precedence. So in a single line section, our crossing is unavoidable, okay, because the trains can start from both the ends and all. So additional tracks are provided in the station section. Okay. Then once a points are provided, they are a source of danger, okay, for safety, because a point not correctly set can cause a serious accident. So not only that the points are correctly set, they should continue to be in the same position. So they have to be locked also. Okay. So all points have to be correctly set and then locked for the safe movement of the trains. So in the case of facing points, if there is a gap, okay, then the trains will derail. Or if it is set to a wrong route, then train may go to a different route which is occupied and all. So that way, the correct setting and then locking of the points are proved in the signals. What is meant by proving in the signals? The signal will not come, okay, unless the points are correctly set and locked. So the station section signals, number one, they have to prove the correct setting of the points in the route. Okay, correct setting and locking. Next thing is the route in which the train is taken. They should be their clearance also to be proved. So how their clearance is proved? By proving the track circuits in the signals. That means if unless the track is clear, it is not possible to take off the signal. Then the other thing called isolation is there. What is isolation? Isolation means suppose a train is running on the main line. There are additional lines connected to the main line. Loop lines are there. These loop lines may be passenger lines or they may be goods lines also. There may be sidings also. So on these sidings, some parallel movement may be taking place. Suppose by mistake, one vehicle escapes and runs onto the main line. Then it can cause a serious accident. So to prevent that, what is called a concept of isolation is used. That means any movement taking place on the loop line, the vehicle, it should not be possible for the vehicle to come and infringe the main line. Okay. So for that, you use what is called a trap points or a regular points also. Okay. So how many people understood about isolation now? Are you able to understand?
Sand hump is provided,
Yes,
sir.
sir. Yes, sir.
Yes. Okay. So as I said, isolation concept, if you understand, the means of providing isolation is by means of either trap points or using sand hump or using a siding point and all, any point also. Okay. So any point will have two positions. One is normal and reverse. Normally, for the loop line to be connected to the main line, it should be in reverse position. So if the same point is set to the normal position, then it is isolated from the main line. Okay. So normally if it is set to the normal, it may be towards a sand hump or it may be towards a siding. Okay. Or it may not be a full-fledged point. It may be a simple trap with only one side open and all. Okay. So in the case of trap also, the derailment do take place, but the main line will get protected. What is important for us? The line on which is isolated from the remaining lines. Normally, the concept of isolation is required for compulsorily for all passenger lines, whereas goods lines need not be isolated from one another. Okay. Then, of course, in the yard also you have got level crossing gates available. Their closure, okay, has to be proved in the signal. So that is the cheapest way of protecting the level crossing gates. No additional new things is required. Already you have got the gate available. Already yard is having signals. If you interlock the level crossing gate with the existing signals, the gate will get protected and all. That means unless the gate is closed and locked, signal cannot be taken off. Okay. Then preventing conflicting movements. So the station, more than one movement is possible. For example, if you take a double line station, up trains and down trains can be simultaneously dealt. So these are the parallel movements. But here, conflicting movements should not be done. That means suppose there is a common loop. Onto the common loop, you can take a train from up direction as well as the down direction. But simultaneously, both the things should not be possible. These are called conflicting movements. So the interlocking will prevent the conflicting movements from taking place. Then allowing safe parallel movements. So what is the best way to avoid accidents? To stop all the trains. Okay, but that is not our intention. We must run as many trains as possible. Okay, at the same time, no accident should take place. Same way, in the yard, you must allow as all safe parallel movements. Okay, no possible movement should be prevented. So that is also done using signaling. Okay. So if you get into the depth of the signaling and all, you have got additional concepts of signaling. Okay, so far we have thought signaling means signal will prove all the tracks, points, level crossing gates, and isolation and provide safety. Okay, so that itself is not sufficient. There are little bit more also. What is that? One is track locking. So what is track locking means? A point. Okay. Points nowadays all are motor operated. Earlier they were all rod operated points. So motor operated point means a point may not be visible to the station master, but still he may operate it with from the panel and all. So suppose at that time there is already a loco available or a train available, then it should not be possible to operate the point. So here there is no signal is involved. Okay, it may be unsignaled move also, but once if any train is available on the point portion, it should not be possible to alter the point. So that is called track locking. That means point portion track circuit is proved in the operation of the point. Then of course route locking. What is route locking? You have taken off the signal. The signal is proving all the points, track circuits, level crossing gates, isolation. So everything is safe. Is it safe? Suppose you prove all these things in the signal, will it ensure safety? मुझे कुछ जवाब
Yes, sir.
चाहिए हाँ?
Yes, sir.
Normally it should ensure. Okay.
Sir,
Normally it should ensure. But imagine what will happen. You put back your signal. Okay. Then you start altering the point.
excuse me, sir.
हाँ.
What is difference between track locking and route lock?
वही बोल रहा हूँ. Track locking is for a particular point.
Yes,
Okay.
sir. Mm.
Whereas
Route
route
locking-
locking is for the entire route.
Route means,
For
sir,
entire route. Okay. For the
आपका
signal.
entire
Track locking is helpful for unsignaled moves also. When there is no signaled movement in the yard, there may be movements taking place without signals also, with hand shunting and all. Even at that time also, track locking will protect the point. Okay.
route locking का कुछ
Route locking means once a signal is taken off, okay, the route is locked, entire route is locked. That means route means say from home signal up to the starter signal, and beyond that some portion are called overlap also. Okay, so this overlap portion also is locked. But even if you put back the signal to danger also, the route locking will not allow the point to be altered. That is called route locking. Okay. Suppose you once your signal is given, then even after putting back the signal also, it will not be altered. Okay. The entire route gets locked. For releasing it, either it has to be cancelled separately or some timing is given. Okay. After a specific time, safe time only, it is possible to
excuse me, sir.
free the points.
Excuse me, sir. Sir,
Yeah,
the
please.
route locking or route holding तो होता है.
Pardon?
Route holding or route locking.
हाँ.
The route holding और route locking क्या difference होता है?
It is holding, it is the route holding and route locking more or less same only. Okay. It is holding the route till the movement is over. Okay. These are the specific words used like this. Normally, holding of the route and all was used when log bars were there. Okay. You know what is a log bar? In the mechanical signaling. Okay. They were
Sir, once route lock होने के बाद क्या सिग्नल फीडबैक होगा?
नहीं, सिग्नल फीडबैक होने के बाद भी आप पॉइंट को नहीं अल्टर कर सकता है.
That is safety.
हाँ, क्योंकि आपका ड्राइवर सिग्नल ग्रीन देख के आपका होम सिग्नल को 100 किलोमीटर स्पीड में अप्रोच कर रहा है. उस समय आप सडनली पुट बैक करने से उसको नहीं रोक सकता है ना ट्रेन को. हाँ, इसलिए points and all should not be altered in the face of approaching train. इसलिए once after putting back the signal, the train may pass the signal at danger, but still it is safe because already safety is ensured by setting the points, locking, closing the gate and all. He may apply emergency brakes and then he may come to a stop. Okay. all this will take place within the next 2 minutes and all. Okay. So once the train comes to a stop, then if it occupied, then no point will be altered. Even otherwise also, after suppose he is able to stop short of the signal, then after a particular time delay, it will be they will be able to alter the point for any making the movement. Okay.
मैंने सर
हाँ.
ये अप्रोच लॉकिंग है ना सर?
अप्रोच लॉकिंग आई विल कम नेक्स्ट. रूट लॉकिंग समझ में आया?
ओ हाँ ओके.
Okay. Next comes approach locking. So approach locking means when a train is coming, okay, you have taken off the signal. Okay, station master has taken off the signals for a train. Thereafter, the controller has given a instruction to change the trains and all. Instead of that train, he says that you receive some other train and all. Then he has to cancel the route. Okay, so he will put back the signal to danger. Then suppose there is a thing called, if the entire track is proven and it knows that there is no train that is being received, okay, then there is no need to wait for that much time and all. Immediately the route can be altered. Okay, so that is called approach locking. Suppose the it is occupied before home signal, some track circuit is there that is occupied. Then in that case, then he will not be able to change the route. Best example is I can tell about the starter signal. Suppose a station master, okay, has taken off a signal, starter signal. Okay, when he takes off the starter signal, if the line is already occupied, okay, then even if he puts back the starter signal back to danger also, he cannot alter the route till he cancels the route and the timer, there is a timer available. After the lapse of the time only, okay, he will be able to alter the route. Same thing, suppose if the track is, there is no train on that, and here he takes off the starter signal. Okay, then as soon as he puts back, the entire route can be released and all. Okay, so the approach locking is the train when it is in the approach portion of the signal, if it is occupied, the route will be held in the position. Okay, it will not be altered. That is approach locking. Similarly, back locking means suppose a train has passed the signal. As soon as the train passes, immediately if he puts back the signal, then is it possible to alter the route? Because train has already passed the signal. Okay, but the thing called backlocking will take care of it. That means the route is held, okay, by the backlocking. Even after the same train passed, then it automatically goes back to danger. No, station master need not put off. Once the signal is passed, the signal has already gone back to danger. Even after signal has gone back to danger also, your route is held in that position using what is called backlocking. Okay, so you don't have to know in depth about it, but these are the various concepts of signaling which is used for holding the routes and then providing the necessary safety. Similarly, there is a thing called sectional route release. In small way stations and all, the entire yard is locked, and after the train passes, the entire yard gets released in one go. Okay, but in big yards and all, your entire route means it may consist of some large number of 2 kilometers and all, involving number of points and all. Okay, but your movements are too frequent. So there what happens is the entire track is divided into smaller sections. Every point is treated as one section. Okay. And as soon as that particular point is completed, movement completed, that particular point separately gets released and it allows the alternate movement to take place immediately. Okay. So that is called sectional route release. Similarly, point to point locking. Suppose you have got two loop lines in a single line section. Okay. So both the loop lines in reverse direction, is it required at any time? So it is not required. So conflicting type of point movements where it is not feasible there, that can be locked through what is called point to point locking and all. So these are the various things which are incorporated in the signaling. If you get into the thing, okay, you must have a basic understanding, that is sufficient. Okay. So another
Actually,
thing,
sir,
yeah,
back locking also. Back locking.
pardon,
Back locking.
track locking.
Yes, sir.
Track locking.
Yes.
Track locking means the same thing. If a particular portion, track locking is used mainly for point portion, number one, where point is there. And the point portion will also have a track circuit. So if that particular track circuit is occupied, then the point cannot be altered. So no signal is involved here. Okay. Simply, if the point portion is occupied, point operation is not possible. Okay. So that is track locking. So the important point in trackside signals is your entire safety depends on the driver following the signals. Okay. Suppose you provide the signal cannot be taken off when this is there, when that is not there, and all, you provide all the safety. But still, if the signal is red also, if the driver doesn't obey, no safety will be there. Okay. So the entire safety depends on the driver adhering to the rule that he will not pass the signal at danger. But the thing is, why should a driver pass the signal at danger? Okay. So the driver may not be able to do, because some of the reasons why signal passed at danger can take place is, number one, maybe a brake failure, is unable to control the train, or he may not be alert in observing the signal. Okay. So or he may pick up the wrong signal. This normally happens in yards and all. Okay. If he is not thorough with the yard signals and all, he may pick up the adjacent track signal, okay, which is meant for the other train, which is showing yellow or green, and he may start his train movement. Then also he may pass his own signal, he will pass at danger. Okay. Not familiar with the section also. Normally learning will be given for them. Practice sections are given for becoming familiar with the section and all. Suppose if they are not familiar also, so he must anticipate and be alert in stopping the train while approaching the yards and all. Okay. If he is not alert, suddenly he may approach the signal and all. He may miss the signal, seeing the distant signal, and straight away he may approach the danger signal and all, where he will not be able to control the speed of the train. Before that, he may pass the signal and all. Okay. Then unsignaled moves are also done in yards and all. So in that case also signal doesn't protect. If the trains are backed or moved in the reverse direction. So normally the presumption is that all trains will move only in the forward direction. But if some backing is
up and
done,
down,
lot of
arrival of the-
precautions has to be taken.
or before the
Okay.
person
So GR and all
to-
mentions how a
first
train has to be moved in the reverse direction for any requirement.
promise के लिए भी
Okay. Lot of care has to be taken. If that is not done, then your signals will not be able to protect. Okay. Then of course, in the case of block section, parting take place also. Earlier, they were not protected. Now with BPSC, hmm, provided that is also taken care of. Okay. Then of course, if a wagon rolls into the section also, your signaling will not be able to protect. Suppose you have your block section is there, your everything is clear, proper line clear is taken, a train has entered the section. Okay. But from the other side, if some wagon rolls into the section, then also it can cause an accident. Okay. So if track is infringed, a double line section is there, on one line train derails and causes infringing to the other track, then also your signaling will not be able to protect because there is no provision for proving these things. Okay. So in 1 hour, this much of signaling only is possible. Okay. So further, if you want to know more, okay, you have
Sir,
to
excuse
have
me.
separate interest and all. Okay. So,
Sir, excuse,
PPT भेज दीजिएगा.
sir, excuse me, sir.
yeah, please.
Sir, in the initial portion of this PPT, SPAD is written. What is the full form of SPAD?
SP, SPAD,
SPAD.
signal passing at danger. Normally, SPAD cases,
Okay, sir.
mechanical department, electrical department operating, they use the word SPAD. SPAD cases while discussing. Okay, there were two SPAD cases like that. SPAD means signal passing at danger. Normally, as I said, the entire safety is done by the loco pilot following the signal. If the loco pilot doesn't follow the signal, then serious accident can take place. Either it may be within the block section or in the yard section. Okay. So that is why the minimum punishment prescribed for drivers in the accident manual is removal from service. Okay. So the driver has to be very alert. They have been drilled into the concept that they should never pass the signal at danger. Okay. So of course now the things have become easier because they have got walkie-talkies and communicate. At least they will be communicated if there is a delay. Okay. Sometimes what happens, some major problem may be there. For hours together, they may have to wait at the signal. Okay. Despite that, they cannot move the train. Okay. But what they can do is they can send the assistant to the station to know what has happened and all. Okay. But of course, with improved communication, now they have got the information why a particular train is held and all. Okay. So SPAD is considered as a very serious thing as far as loco pilots are concerned.
Sir, send PowerPoint, sir.
Yeah, this PowerPoint is for I think maybe for 10 hours or so. It is having lots of information. It is for initial courses and all. Okay. I can
Okay.
share the PowerPoint, but I have only covered a few slides and made you understand the basics of signaling. What is that? Basics of signaling is number one, automatic signaling and absolute system. In the absolute system, you have got station section and yard section. Station section protection of signals, what it serves, what purpose it serves. In the yard section, what protection it gives. Okay. So all these things is entire thing, whatever we are providing in signaling, again depends on the driver passing, following the signal. So for protection against FAD, again you have got the additional things available that is available in only few sections that is coming. That is called this auxiliary warning systems, train protection warning systems, TPWS. Okay. Then you have got this latest ETCS level 2 and all are coming. That is to help the driver. Okay, in case if he makes a mistake and passes the signal at danger, it will not result into a accident. Automatically, the uh, brakes will be applied and train will be protected. Okay. Okay, shall we close?